Hello, differential equation students, and welcome back to unit number 5, our last unit, and we're on to 6.3. This will be an introductory video to power series about singular points. So far what we've done is we've done ordinary points, and now what we're going to do is we're going to try to tackle some power series solutions about singular points. So we're going to need this theorem down here. So it says if x equals a is a zero of the polynomial a sub 2 of x. Well, remember that we placed that out in front of our very first one, right? So usually this is like on a second order. We would have y double prime. Whatever is sitting out here is that a sub 2 of x. And we also talk about x minus a and x minus a squared being analytic, which we talked about all the way back in 6.1. And basically we're saying there exists at least one, right? At least one power series solution of, well, what do we usually have our series equal to? Well, it's y equals, and then we have n equals 0 to infinity of c sub n, x minus a to the n plus r, okay? And then what we've done kind of in the past is I've walked us through our first derivative. So if we assume that this is the answer here, right, then y prime would equal, well, there's a couple different ways to do it. Of course, if a is some number in here, it gets a little bit more tricky. So here in general, because we're just now learning about power series solutions, let's just let a equal 0, which would then be y prime is equal to the summation n equals 0 to infinity. I would have my c sub n. Okay, now taking the derivative of this, right, well, the power would come down, so that's n plus r, times, well, it's x minus a, but remember, a is 0, so that's just an x, and then it's n plus r, and then that's minus 1. Likewise, if I go and I try to do the second derivative, it's a summation of n equals 0 to infinity of c sub n, n plus r, same thing, right? And now this thing has to get dropped down, so it's n plus r minus 1, and then it's x to the n plus r minus 2. And of course, we're going to need this general solution here, and how the derivatives work with it when we go to try to tackle a problem. And this is actually the introductory video then for 6.3. I'm going to stop this video here. It's nice and short. Okay, make sure you have these notes down. And then the next video to come, I'm going to actually solve out one of these problems. And if I have enough time, I will create one more video with a second example problem solved.